So this is one of the examples of computer vision. Next, we have object detection. So object detection can use image classification to identify a certain class of image and then detect and tabulate their appearance in the image or video. Examples include detecting damages on an assembly line or identifying machinery that requires maintenance. If you have a machinery, you can like give the inputs of the perfect machine, okay, like the ones which do not have any defects. You can give inputs of those and the computer model will try to learn it, and then later if you like give a defect image, it will try to differentiate it. So this is one of the other applications, which is object detection. Then you have object tracking. A famous example for this is autonomous vehicles or self-driven vehicles. So how do you think a vehicle can drive on its own without a driver? Like, is it even possible? Using computer vision, this is possible where you're given a lot of inputs of various roads, like it may be like road lanes or many any obstacles, whatever is there in the images, it will try to learn it and then it can differentiate which is the road and which are the obstacles. So object tracking, then content-based image retrieval. So these are the various applications where computer vision can work, and it is widely used nowadays. Uh, Self-driven vehicles or autonomous vehicles, it's very common nowadays. So uh, these are the various applications. Yeah, so here you can see this image where it is nothing but the road lane detection. So you can see how the computer can detect the obstacles on the road or the edges of the road. So how does computer vision work? Computer vision needs a lot of data. So one or two image won't work. You have to give a lot of input. Seeing the various inputs, it will try to learn and then it can conclude that, okay, this image means this. Okay, like for example, you want to differentiate different animals like cats or dogs. You have to given a lot of input images and then only it can differentiate that this image is of a cat and this image is of a dog. So that is the basic idea. It runs analysis of data over and over until it discerns distinctions and ultimately recognize images. For example, to train a computer to recognize automobile tires, it needs to be fed vast quantities of tire images and tire related items to learn the differences and recognize a tire, especially one with no defects. Two essential technologies are used to accomplish this, a type of machine learning called deep learning and convolutional neural network. Okay, so this is a basic application of AI. So under AI, it comes under deep learning and there is convolutional neural network. Machine learning uses algorithmic models that enable a computer to teach itself about the context of visual data. If enough data is fed through the model, the computer will look at the data and teach itself to tell one image from another. Algorithms enable the machine to learn by itself rather than someone programming it to recognize an image. So this is basically the theory of whatever I explained right now, the applications and all of that. You can read this later. I'll upload the PPT on Teams itself. So later on, you can read it, and if you get any doubts, you can ask it on the Teams itself. So now we come to the basic operations which we'll be doing in OpenCV. So we'll be learning OpenCV using Python. You can use any other languages also like C++, etc. For that, you can like refer the internet anytime. We'll be discussing using Python. So first, I expect you all to have VS Code on your PC. Do you guys have VS Code, or should I like give you a guide to install VS Code? This is the first session, so it's fine. But from next session, we expect you to have VS Code on your PC. You guys know what is VS Code, right?
Yes, yes, yes.
Okay, okay.
VS Code, like which one do we have to use C or C plus or
In VS
Python?
Code, you can use any language. Oh, this is VS Code. It's a compiler. So I'll just upload a video to install VS Code. You can install it and keep it ready for the next session. So for this session, it's fine if you don't have it. Uh, you'll also have to install some Python libraries. So all of that I'll just put it on the chat box later on after the session. Uh, so I'll just start with the basic operations. So first, I told you that for OpenCV to work, you'll have to give a lot of input data, which may be in the form of images or videos. So for that, right, first the computer has to read the image. So we have predefined functions like imread, which is like for the computer to read the image. You pass in like you first have to import the OpenCV library, import CV2, and then to read the image, you use the predefined function imread, and then in the brackets you put the path of the image in your PC. Wherever the image is placed, you will have to put the path of it here inside the braces, and then to extract height and width of the image, you have this function here. And if you want to display the height and width, then you'll have to put print and height, width, all this. So here I'll just show you. Okay, so first in VS Code, you'll have to open a workspace. You can name it whatever you want. I have named it as OpenCV, and then you'll have to open the folders which have your input. So here is my input, which is photos. So under photos, I have two images. One is of a cat, and the other is of just a random picture. So this is the input you'll be giving, whatever input you want. Then you can also include videos here in other folder. And these are nothing but the Python files which I've made here. So first we have the read file where we'll be reading images. So first you have to import CV2 as CV. You can actually just import CV2, but for more easier uh, application, I have imported CV2 as CV. So first we'll be checking how we can read images. So I have the function imread. I'll be passing in the path of the image, which is like stored here in photos. I'll be having cat image. So this I'll pass it here. And then I want to see like what the computer has read it. So I'll be like putting im show, which will show me what the computer has read. Okay, so here I pass in one argument, which is nothing but cat. So this is like, it will name the window. Okay, the new window will open when the image is shown. So I want the window to be named as cat. You can put whatever you want here. And then you have to pass this image here. And then you have something called wait key. Uh, and inside the bracket, you have 0 here. So wait key is like the duration for how much you want the image to be displayed on the window. So here you can put 1 second, 5 seconds, 10 seconds. You can put anything. If you put 0, it means the image will be displayed for infinite time. Or if I leave the brackets empty, it means it will be displayed only for 1 second. So this is what this code means here. Now we'll be checking for reading videos. Again, there's a predefined function which is video capture. You'll be passing in the path of the video. Uh, One more thing is like this is a pre-existing video on my PC, which has a path. But what if I want to read a live video? Suppose you have a web camera and something is going on in front of the camera, and you want the computer to read that video. So at that time, what you're gonna do? You can just pass in some integer, okay? It may be 0 or 1 or anything. Uh, if you have some PCs will have more than one web camera, so at that time you can pass in whichever integer indicates that camera. So you can, in the place of this path, you can just put the integer 0 or 1, and that will capture the live video. So here for videos, there's a problem. Like video is a continuous display of different images, right? So here there's no direct thing like here what we have in read. So here we'll have to like break down the video into frames. So we'll be using a while loop here. While true is true. So we have frame here. We'll be capturing it and reading it. So then after that we can, if you want the to display the computer to display what it has read, you can do imshow again here. So for videos, we'll be working on frames. So again here, uh, so this is like if you don't want the computer to read the whole video, then you can use a if statement and put wait key as how much ever seconds you want the computer to read the video. Suppose the video is like 1 minute long or 2 minutes long, and you just want the computer to read the first 20 seconds of the video, then you can just pass in if statement cv.wait key, and you can pass the duration of the video of how much you want the computer to read, like out of the full video, just the part of the video where you want the computer to read. So you can pass in that time. And this is something complex, so we'll keep this aside for now. Then you have the break statement where you want to get out of the loop. You have capture.release where you'll be like, then you'll have to use this destroy all windows where you want the uh, display window to close. You don't want it to be like open, so you'll destroy all the windows. And then this cv.wait key 0 is for the whole video. Okay, the im show here. This is just for reading, like how much part of the video you want it to read, and this is for like the video to be displayed. So I'm putting it as 0. So to check this, we'll just run this code. So this was the image I passed in through the path, which was on already on my PC. Uh, so I told you that the name of the window, I have put it as cat. So this is how it is. Since wait key is 0, this image will be displayed for infinite time. So till I close the window. And this is the video, what was there with the video I passed in. So yeah. So this, I told you that I've passed in like wait key 20. So it will be like, it will play for 20 seconds and then it will close on its own. So this is reading images and reading videos. Uh, Now we'll check to how to like resize and rescale the images or the video. So first, we'll have to import CV to our CV, similar same things like whatever we did there. We'll have to read the image, and you can also show the image. And now we'll be using a rescale frame. So we'll have to pass the frame, and then you'll have to scale the image. You're scaling the image to whatever percentage you want. You can put it as 75% or 25%, whatever. You will rescale the image to 75%. So that's what it means. I'll be passing in width. Uh, so shape of one represents width, and I'll be rescaling the width to 75% of the width. And I'll pass this into a variable called width. So this is what it means, and height is here. And then I'll pass width and height into dimensions. Okay. Then I'll be returning cv.resize, uh, frame dimensions and interpolation here means here we'll be working on iterations and all that. So you have different types of interpolations. We'll be using inter area here. There are other types where is interlinear and intercubic. It all depends on how large is your image, and it also depends on quality of image. So you can use different interpolation options here. Then I'll be passing rescale frame. I want the image to be displayed in a separate window called image resized. So then I'll be like using the wait key 0. So we'll just check how this will run. Yeah, so you can see this was the image, previous image, and now it is scaled down to 75%. So this function rescale frame, which I have defined over here, this is not a predefined function. I have defined it here. So this function can work for images, videos, as well as live videos. But for live videos, you can also use another function here. I have defined one more function. So this works only for live videos. Again, this I'll be explaining later. So for now, let this be here. Uh, so now we'll check how we can resize a video. So again, a video capture. This is like the reading part of the video. Uh, Again, you have here while statement because we'll be working with frames and rescale frame again. So here, what I've done is I have defined here already like rescale frame uh, function. So I'll be using the same function here for video. So frame resized is equal to rescale frame, and then I'll be showing the video whatever has resized here. So everything else is the same. So when I run this, I'll get the resized video also. So this is 75% resized compared to the original. So this is the resize and rescale function. So now we'll move on to the next part, which is like drawing different patterns on an image, or it can be writing text on an image. So again, import CV to as CV. Here we'll be using one more library, which is called NumPy. This is basically used for mathematics. Okay. So import NumPy as NP. So here what we'll be doing is we'll learn how to write uh, or draw different patterns on a blank image. Okay, you can do this on any image. Like I can do this all these operations on cat image itself. So for that, I'll have to write imread again here, and then I can do all these operations on that image. But for now, just to understand, we'll do it on blank image. So to create a blank image, I'll be using this syntax. So np dot zeros. Np is like again this library here, and dot zeros means a zero represents black color here. So if I put ones here, ONES, it will create a blank white picture. Okay, so then I'll be passing in this 500, 503 represents blank image. 3 is nothing but the channel here, okay? Again, I got channels, I'll explain later here. And the data type for image is nothing but uint8, okay? It's unsigned int 8. Uh, then I'll be like showing this blank image in a new window with the name blank, and I'll be passing in this variable here. So first we'll be checking how to paint an image a certain color. So here we have blank image which is black in color. So if you want to paint that blank image some other color, for example green here, then we can do that as well. So you'll have to pass in the blank image. So here I am resizing the image here to like 200 is to 300 and 300 is to 460. And here these three variables represent BGR, okay, which is blue, green, and red. So I'm putting BGR is like the basic uh, color format. Here, if I put 255, 255, 255, it will represent white color. If I put 000, it will represent black color. If I just put 255 here, it will represent red color here. Okay, so actually here there's a mistake. So this should be 0, 255, and then 0 here. Now this will represent green color. So I'm going to get im show green. So that's how you paint a image a certain color. So from blank image, I go to green color image here. So next we have draw a rectangle. Okay, so again, cv dot rectangle, it's a predefined function here. So I'll be passing in the blank image here, and then this is like the first point. Okay, the rectangle starts at 0 comma 0 and it extends up to 250 comma 250. So this is like the starting point of the rectangle on the top left corner, and this is the bottom right corner, and this represents color. So I think you can guess the color here again. So it's blue, green, and red. So this represents green color. And then I'll be telling the thickness of the lines. Okay, thickness is equal to 2. Suppose I want the, here it will like give me a hollow rectangle with just the borders being green color, and the thickness of the borders is 2. But suppose I want a solid rectangle, like a whole rectangle being green color, then I'll have to put thickness is equal to cv dot filled. I can use either this function or I can just put thickness is equal to -1. So it will give me a solid rectangle. The whole rectangle will be green in color. So that's what it means. This is like just the same thing again. But here, instead of putting like the ordinates like this, like 0, 0 and 250, 250, I'll be just putting the this, and here I'll be putting uh, half of the window size. Okay, so this is blank dot. I told you that shape 1 is nothing but it represents the width, and shape 0 represents the height. So I'm passing in blank and I'm making the width divided by 2. So rectangle is like drawn for the half of the blank image, half of width and half of height. So you can write it in this way as well. And here, if you see it's 0, 0, 255, so the rectangle will be red in color. And thickness is -1, so it will be a solid rectangle. The whole rectangle will be red in color. Then I want again the image, I want the rectangle to be shown. So I'll put im show rectangle and I'll pass in the blank here. So now we go to draw circle. Again, CV dot circle. Again, one more predefined function. So I'll be passing in blank image. Here 250, 250 represents the center of the circle. So uh, this is the point where it's the center of the circle, and 40 represents the radius. So a circle will be drawn of radius 40 and the center of the circle is 250, 250. So this is the color of the circle. So 255, 0, 0. This is nothing but a blue colored circle. Thickness of the border is 3. So again, im show circle, blank. Uh, Next we go to draw a line. So again, line, blank. This is the starting point of the line and this is the end point of the line. Here, what I've done is I do not want it to be just blue, green, or red. I want some other color. So if you know the which number represents that color, so you can just put it. I just want to put a random color, so I just put 300, 400, and 0. Uh, and here I have thickness is equal to 10. So im show line blank. Now write text on image. So I'll put text. This is again one more predefined function. I'll pass in the blank image. I want the text. You can here you have to put whatever text you want it to display on the image. So I want computer vision to be there. So I want to put this text on the image. So you can put that here. This is the ordinate where the text should be displayed. And then here you have CV dot font Hershey complex. So this is one of the fonts which is already present in OpenCV. So there are different fonts which you can check and you can put the font which you like. And here I have one. This is nothing but scale. Here I have the color 255, 255, 255 represents white color. So the image, the color of the text will be white. And I have thickness too. So again here. So if I run this right now, it's like im show, im show, im show for everything. So it will display all the windows. If you want just one of the window to be displayed, you can just comment out all of this. So we'll just run this. Yeah, so this is the final image of all everything like the rectangle, line, circle, a solid rectangle, computer vision, everything is here. So you can check this. If you just want the rectangle, see you can see here. This is the line window. Uh, so if you see here, actually, like the line window, I had passed in the blank image, and then I, uh, yeah. So for the line thing, I passed in the blank image, but if you see, so according to that, the blank image, just the blank image and the line should be there. But here, what's happening is like I have passed in the blank image, but before that, the blank image had gone through all of this. So it's just the blank image has changed here, and the line has been drawn above that. So if you want just the line, then you can comment out everything and you can just pass in the blank image which you created first, and then you can put the function put line no line, and then you can do the other things whatever we have done here. So this is for drawing various patterns, and here you have putting the text, write text on image. So now we'll go to the last part of the session where we will be discussing about some basic functions in OpenCV. So again, import CV to a CV, import CV to from CV to import inter area. So this is a type of interpolation which we'll be using here. So we'll be importing that. Again, image read. So here I'll be reading the other image which I have here in my folder. So I've passed in the path of the image here, and so this image, when I put show, it will be displayed on a different window, and the name of the window will be this, whatever you pass in here, and then I'll be passing the image here. So first we'll learn how to like display the colored image in grayscale. So for that, I have a function here, cv.cvt color image and cv.color, which is BGR to gray. So this will convert the colored image to gray image, and we'll see how it looks. Then I have blurring. So here we have different types of blurring. I've used here Gaussian blur. If you actually just type blur here, you'll get like the different types. And here I've passed in the image here, and then 3 comma 3 is nothing but kernel. Okay. So again, about kernels you'll be learning in the further sessions. Uh, so here remember that the kernel has to be like uh, odd number. So if you're passing here, it has to be 3 comma 3, or it can be 5 comma 5, 7 comma 7, anything. Okay, so this is like based on matrix and all that. We'll be learning that in further class sessions. Then you can pass in the cv.border default. Okay, there are different types of borders here. You can check it and you can pass the one which you want. Uh, Now I'll be checking edge cascade. So this is nothing but it marks the edges in the image. So this is very important part of the image of OpenCV, where you'll be like marking the edges of the image. So for that you have a function called canny, and I'll be here. I've passed in here. If you see, I've passed in image. Here you can pass in the image itself if you want to detect all the edges in the image. But I have blurred it a bit because I don't want all the unwanted back. Actually, if you see the image here, and if you try to do the canny for this, right, you'll get a lot of edges. Like it, even it will detect the edges of the trees, which is like not favorable. So I'll just try to blur it a bit. Like we'll see this. I'll try to blur it a bit. And now what will happen is, since the image is blurred, it won't be able to detect all the edges. It will only detect some of the edges, and you can modify it in this way. Uh, so next we have dilating the image. So here you have got just the edges of the image. You can dilate it. Dilate it meaning you'll make the edges more thicker. Okay, so it will look better. Uh, so again, you have cv.dilate. You'll be passing in canny here. 3 comma 3 is the kernel, and here iterations are 5. Uh, so again, it will display in a separate window called dilated, and I'll be passing this dilated here. Eroded is opposite of this, so it will be making the edges more thinner. So here you can pass in the image itself, or what I have done is I have passed in the dilated image. So if you see here, it's dilated 3 comma 3 iterations are 5. So here what this dilate did is it took the canny image, it made the edges thicker, and now I'm passing the thickened edges to eroded. So this will return the canny image. So this is what is happening here. You can pass in the image itself, or you can pass in whatever you want, whatever is required. So for resizing, this I've discussed earlier, but there is already a function which is called resize. I'll be passing an image, and then I'll be passing in the like the size of what I want, like 500 comma 500 is the window size. So I want it to be resized to this, and cv dot inter area again. This is interpolation option. So there are other options also, which is interlinear. When you just type inter, you'll get some suggestions here. So I recommend you to use VS Code. So most of the times we'll be using inter area itself, but if you have very large images, or it also depends on quality of the image, then you can use other interpolation options like interlinear, intercubic, etc. So this is the resize. Cropping of the images, like resizing is like you're resizing the entire image to a smaller size or whatever size you want. Cropping is like where you'll break the image where, like, to whatever you want, like to what you specify here. So I'm breaking the image to this dimensions. So this is how cropping works. So again, we can run all of this and check. Okay, so here you can check the cropped image. Uh, this is the resized image. Uh, okay, for this you'll have to like check the. So this was the first function which we checked, which is grayscale, converting the colored image to gray image. So this is a grayscale. This is the blurring. So let me check this, and this is the original picture. This is the canny edges where it only like marks the edges in the image present, the different edges. So here it is like almost all the edges are marked. So this is dilated where you thicken the borders or the edges which is present in canny. This is eroded where it thins the borders. Yeah, so this is it for today's session. So we have learned how to read images, read videos, rescale and resize the images and videos, uh, draw different patterns and write text on the image. And we have also learned different functions which are available. So these are the basic operations which we have done on the image. So if you have any doubts, you can ask me now. I'll be uploading the PPT and all the codes what I've used in today's session in Teams. So you can try out all of that on VS Code, or just try running those codes. And if you have any doubts, you can ask it on Teams itself. If you guys don't have any doubts, you can leave the session.